So what is static? Static is something, according to the dictionary, that is showing little or no change, something that doesn't change frequently. You call that to be static. We'll understand static by considering a scenario. First, let me write this program. This program contains three student objects. So I'm going to create three student objects, and these are the data members for my student objects. That is name. Every student has a name, registration number, and the university name for that student. And we'll have some four methods here. That is, the method one will be setting all the details. We'll be getting and setting all the details. Get details is for displaying or returning all the details for every student. And total students, we just want to print the total number of students in our university. So that is the count. Total will be printing the count of objects, or else we can say this will print the count of objects in our system with respect to students. And display university address, this method will be printing the university address, and it will be part of the student class. So this is the exercise that we are going to take in today's class to understand what is static. First, let me go and code this. We'll create three student objects. Why don't you start coding parallelly with me? So we'll have class student, and we have let's make everything public here. Public string, we have name, and public string, we have registration number, we have public string, and then say I will say university address. Yeah, something like that. Next, let me go and have a method for setting the details for the student. So this is the method. It's a public method, and we'll call this set details. Let me delete this line. Here we need to have a scanner class to get the input from the user. So let me say scanner input is equal to new scanner system.in, and we'll have the input received from the user. So name is equal to input dot next line. And we can also have a sysout statement so that our output is far better. So sysout, that is enter the name. Next thing is we'll get the registration number. Again, we'll have a sysout. We'll say enter the registration number. Just giving some guidelines to the user. So he enters the registration number. We'll capture that in registration number. It's next line. Okay. Next thing is we'll ask the user to enter the university address. Let's have a sysout here, and we'll say enter the university address. Now we'll go and scan this one in the university address, that is equal to input dot next line. So we have finished reading the details. So this method can be used, and we'll make it a public method, not a private one. Okay. The next method we thought of was get details, that is it will return the details of any student. So it's public void, it will return. So let's say it returns a string, and then the method is get details. So what it's going to return is it's going to return something, return name plus registration number plus university address. So just a string is getting returned. The details of a student will be returned by this get details. And we thought of another method too, that is display the count of students. We'll come to that later. For now, let me have this method to print the university address. So it's public void print address, something like that. And what's going to do is it's going to say it's just going to print the university address. So it is the university address is, and it's going to print the university address for that student, that is university address. Okay, I've finished coding the student class. Now let us go and create three student objects. The first object we'll create, that is student S1. We'll go and get set the details for the first object S1 dot set details. Next we'll go and create the next object, so that is student S2, and we'll set the details for student S2, that is S2 dot set details. Now we'll create the third object, that is student S3, and we'll set the details for S3, so it's S3 dot set details. So once when you have set the details, we'll go and print the details of all these students. We'll have a sysout statement. We'll do S1 dot get details. So I'm just putting it in sysout because this one returns a string. Likewise, let's repeat for all the students. So S2 dot get details, and again a print statement wherein we're going to do S3 dot get details. And we'll also check whether the print address function works. This print address, how it works for one of the students. So I'll say S1 dot print address. So we have created three student objects, and we have a dot set detail method invoked for all the objects. So the data is set, and then we are printing the data from all the objects. We're also printing the address. Let's go and run this one. Control S and Control F11. So we'll start entering the data. So for first student, Satish, 12 BCE, and Vellore VIT. And second student is Ram. Registration number is 13 BCE, Vellore VIT. All students are from the same university. Let's take it like that. So for the next student, it's Jeff, and the registration number is 14 BCE, and again he is from Vellore VIT. So now the get details will print all the data for all the objects. So this is printing the data for all the objects, and this is the print address method working for student 1. The university address is Vellore VIT. So our code is done. Now you have to understand how memory gets allocated and where these reference variables S1, S2, S3 actually reside, whether on the stack or on the heap. How this data for these objects, student S1, S2, and S3, the data for these three student objects, how it is held on the heap. We'll go to visualization, we'll see how this is actually being done. So we have this heap storage, which is the larger part of the storage in your RAM. And we have the stack. A stack is a limited storage assigned for each application. So it varies in MBs. So for your main method, there will be local variables for your main, right? That will be allocated on the stack. So what are the local variables you have on the main? It's S1, S2, S3. So these are the actual uh, variables that will hold reference to our objects on the heap. So this heap is the larger area of your RAM. So whenever an object is created, the address of that object is stored in S1. Say when I say S1 is pointing to an object, it is pointing to a location on the heap, and it's holding the address. Say if this address is 112, so S1 is going to hold this address. So this variable is on the stack, whereas it is pointing to an address on the heap, which is holding the actual data. Say here, if this is the first student, his registration number and his address. So in this address, we are holding the data for one of the students. Likewise, for S2, there is a separate address. Say if this address is 113, what will be the value of 1 S2? It's 113, and it is pointing to a location on the heap where it is holding the data for second student. Likewise, S3, if this is 114, this address location where this object is, and you see the data for that particular student is stored here, and S3 will be holding 114. So stack, say this area, we call that to be the stack data structure. For main method, all the local variables in the stack will be here. So once one main method goes out of scope, obviously the stack will be emptied. So now you have some understanding of how objects are getting allocated and what is stack and heap storage. Now the next question that comes to our mind is, so we created these three objects, and what we see here is in these three objects, you see, say if all the students are from VIT University, then obviously this field university is equal to VIT. This field is going to be the same for all the objects, right? For all the objects, this is a common field. We can say university name to be common for all the objects. So when we allocate it separately, you see you're taking some storage here in bytes. We are taking some storage here in bytes. We are taking some storage here in bytes for university. So instead of wasting memory like that, when some field is common to all the objects, what we can do is we can put that in a separate area. We call that to be a class or method area. It's also part of the RAM and part of the heap, but it's a separate area wherein you're going to put this university. We're going to allocate university is equal to VIT, and it's going to be common for all the objects, and that will not be allocated. See, VIT university will not be part of the objects, but it will be part of a common area from which it is available to all the objects. So how these objects can access this particular variable is it can just use the class name dot variable name. So it is not specific to any object. You call this object to be S1. We cannot do S1 dot university anymore, university address. We cannot do S2 dot university address because that variable is not here. It's not specific to an object. So how to actually access it? It's nothing but student dot university. Now we use the class name dot university. That is the variable name. Why we don't use s1 dot object name dot that field name? Because it is not part of an object. So this kind of variable that is common to all the objects and that is allocated in a separate area called class area or method area, and it is initially loaded and initialized. This is called a static variable. So what is a static variable? It is common to all objects and it is accessible by using the class name, and it is loaded and initialized in a separate area called the class method area. So like that, we can have more static variables. The count. I told you we should find the count of all the objects. Say if I have a variable by name count, where it will be. Say if I have count to be here, and if I say count is 1, when I go and create this object, this count will be initialized to 0 and will again start from 1. So when you have count to be part of an object, that will get initialized again and again. But we need a variable that should be only initialized once and never initialized again. So that kind of a variable again becomes a static variable. So that it's common to all the objects. Whenever an object is created, I'll go and increment count. And how can I access this count? Again, I can use the class name dot count. So this is the class area. Class area is where the bytecode of your class also is getting loaded. So all the static variables are also present in your memory area called the class area, and sometimes they say it's also method area. So now I hope you have a better understanding of what is method area, what is heap, and what is stack storage, what is a reference variable, what it's actually pointing to, and what is a static variable. So what are static variables is a variable that is common to all objects. It's not part of any object, any specific object. You don't need an object to actually call a static variable. A static variable is initialized only once. That's what I was explaining in the previous slide. If I put count inside an object, it will get initialized to 0 every time I create an object. So we need a static variable so that it gets initialized only once. From then on, the count gets increased. Static variables can be accessed only using the class name. So the student is the class name and university name is a static variable. You give student dot university. We don't give object name here because university is no more part of an object. So how do you declare variables? One sample is given. You can give the access specifier. Static is the keyword, the data type, the variable name, and then you can go with your initialization. So now let's go and change your code to make the university name to be a static variable because we found that university name is common for all the students. Okay, now our objective is to change this one particular variable to be a static variable. Then it will become common to all the objects and we have to initialize it to value VIT. We'll go and make this change. We'll see how to do that. So we're just going to give the type a static string university add, and then we'll say it's Vellore VIT. We assume that everybody is from Vellore VIT. So we are given the university address here. So it's by default initialized to Vellore VIT. So no need to get the input from the user again and again. So here we are reducing the number of lines of code. We are saving some memory also here. So that's the catch. And that's it. So the only thing is we have to see whether this code works like it worked earlier. There are no changes except for making one variable to be common for all the objects. And let me show you here. So now Satish, registration number 12 BCE. See, the university address is by default common to all the objects. So no need to give that. Jeff 13 BCE and Tom 14 BCE. So you see here, this exactly works and it prints Vellore VIT to be the address for every object. But then this Vellore VIT was a common assignment. It was in the class area. From there, every object was able to access that and print the address. And it's not specific to every object. Vellore VIT is not common to every object, but it is from the common area called the class area. So that's how static variables not only save memory for us, but also reduces the number of lines of code that we need to write. I hope you are now clear with what are static variables and how to use them. Let's move forward. Not only variables, a method can also be declared as static. Why should a method be declared as static? What is the advantage? Say you have a method, some display method, something, and you can declare a method to be static. What is the advantage? See, there is no need to create an object to invoke a static method. That is the important advantage. What is the advantage you get when you don't create an object? You don't assign memory. So you're saving some memory there. So without creating an object, if you can access a method, you can get the functionality done in your system. Why should you go and create an object for that? As you've seen in the visualization, an object creation takes some space. And that is an unwanted step. So if you have something that can be done without creating an object, you have to do that. So in such cases, you have to perform that in a method that is declared as static. The important advantage here is no need to create an object to invoke the static method. Method invocation happens using class name. So if the static method is in the class student, so what happens is how will we invoke this display method? We will say it is student dot method name display. So we don't need an object to actually access it. So this is the sample for declaring a static method, public static void. So give the access specifier, static is the keyword, return type of your method, and display is the method name, and then the method body. Okay. So now let us go and take an exercise, that is we'll print total count of objects in my system. Maybe total count of student objects in my system. So to print total count of student object in a system, we don't need another student object for that, right? So this method that is printing the total count of student objects will be printing a static variable called count, which you have seen in that visualization. So this method, we don't need another student object to print the total number of students in your system. So we are skipping the creation of an object for this by making the method static. We'll now go and take a look at that, how to print the total number of student objects. So we'll go and change our code here. So what we have to do is we have to write a method. Let me write it here. Let's have this method that displays the total number of student objects. So it's nothing but public static void display total students. And we need a count of the students. Again, count is not specific to any student object. And as I've shown in the visualization, count is a static data member. So we'll go and create this static variable count. So it's public static int count is equal to 0. So it's initialized to 0 once. From then on, whenever an object is created, this will be incremented. This will not be initialized again. That is the concept behind the static variable. Let me go with the constructor here. So whenever an object is getting created, what I'm going to do is I'm just going to increment count. So count will go from 1 to 3 whenever objects are getting created. And in our static method, we are just going to print the total number of objects. So sys out, we'll just say the total number of objects is, we just print the static count. That's it. So we have used a static method and we have used a static variable here. Now comes the catch. Okay, let me go and remove this. If I want to print the total number of objects in the system, how to invoke a static method? Should I go and create another object? No. So no need to create another student object to invoke uh, our display method, display student total method, display total students I get. What is that method? Display total students method. Because it's static, so we don't need another student object. What we can do is we can use the class name student dot display total students. That's it. So you invoke a static method using the class name. Please keep this in mind. So let's go and see whether we are going to get the total number of student objects. How many objects we created? 3. So the count should be 3 here. Let's execute this. So we'll go and enter the data for our objects. So it's Satish and 12 BCE, Ram and 13 BCE, and Tom and 14 BCE. So we created 3 objects. In the get details method, we are getting the 3 objects, and then the total number of objects here is 3. So that's how you use a static method. You invoke the static method only using the class name. Okay. That's all about static method. Let's see some properties of a static method. You can access only static variables inside the static method. You can't access class variables directly inside the static method. For instance, I have this display total students, right? I can't just go and access a class variable like this, say sys out. I can't just print name. This will throw me an error because a static method is not specific to any object, and when you want to access name, you need an object to access name. It is s1 dot name or s2 dot name, whereas a static method is for a class level method, and you cannot really access name like this because this doesn't configure to anything, right? What is the meaning of this? Is it s1 dot name, s2 dot name, or s3 dot name? No, because this is a class level method. This is not acceptable. So you cannot access non-static variables inside a static method. Please keep that in mind. Can invoke only static methods. Say I have display total students. From this method, I can't call print address. So I can't go and do that. Say if I call print address, immediately there will be an error because print address, we need an object to actually access print address. So it's s1 dot print address or s2 dot print address. Whereas when I say print address here, this will not be resolved as S1 or S2 or S3 because static means it's a class level method and there will not be any resolution like that. So we cannot access a non-static method from within a static method. Okay. But I can very well do this, right? This is a non-static method. I can go and access a non-static method from here. For instance, I can do uh, get details. I can very well perform this. Why it is allowing me is this will resolve as s1 dot print address if it's for object s1, and this will resolve as s1 dot get details. Whereas when you talk about a static method, that is not possible because it is a class level method. That's another property. And the keyword, this keyword cannot be used with static. Obviously, say I cannot print any of the non-static variables here. So I cannot just do sys out and I cannot do this dot name. Because what is this? There is no object here. So for this method, there is no object attached to this method. So when I say this, it doesn't have any meaning. Whereas when I perform the same thing in a non-static method, so actually this dot name has a meaning, right? We'll call s1 dot print address. So object dot name. So s1 dot name will be the actual meaning of this dot name, because this is a pointer pointing to the current object. Since we don't have an object in place here, so from within a static method, you cannot use this keyword. You cannot use the super keyword too, because again there is no concept of object creation with respect to static. Another very important thing, static methods can be overloaded but cannot be overridden. So you can always overload a static method. Say I can very well have another static method, display students, and say I'm just going to get a string. I'll just get a string test. So I have two static methods. Now I have overloaded this. I can say this is from the overloaded method. So I can very well overload it, and now I can go and invoke these two methods like this. Let me go and invoke that. Say this is one of the things without the parameter. The another method can be invoked like this: display students, and then you pass some string, say Satish or something. So now we have overloaded the static method, but then the invocation is always through the class name dot method name, and that is possible. Overloading of static methods is possible. And when you run this, you're going to get two outputs, the total count, and then this is from the overloaded method. You want to check that, you can go and check that. Control S, Control F11. Only thing is I need to enter the output again, inputs again and again. So it's okay, Satish, 12 BC, Tom, 13 BC, Ram, 14 BC. So you see here, this is from the get details, and total number of objects. This is from the first static method. This is from the overloaded static method. So what we understand is static methods can be overloaded. That is another very important thing that we understand here. Whereas this one also we have to check. Can a non-static method call a static method? Can we check that? So this is print address is a non-static method. Can it call this static method? So what we'll do is we'll just go and do display total students, and then we'll pass Satish. A non-static method can very well call a static method, and you can call it even using the class name student dot display total students. So this is possible. From within a static, you cannot call a non-static, but within a non-static method, you can call a static method. So this should work fine. So what we'll do is we'll just go and perform this here. Let me comment everything or delete everything. What I'm going to do is I'm just going to call print address using an object s1 dot print address. So now it should call that static method, and it should print the value out. Let's go and run this one. So it's so Satish 12 BCE, Ram 13 BCE, and Tom and 14 BCE. So you see here, this is from the overloaded method. University address is Vellore VIT. So how this is happening is this method actually calls this static method. So this is from overloaded method, and the university address is Vellore VIT. So you can always call a static method from a non-static method. That is possible. That's what we have learned. Yeah, we have already changed our code and we have understood all these concepts. So that is done. I hope you are now clear with what is static and what is non-static, and what is a static variable and what is a static method, and what are the properties of a static method. There is another concept called static block in Java programming. What is this static block? It's used for initializing static variables. Say if you have two or three variables, you can initialize that. We've already seen initializing static variables, then why we need a static block? See, there can be certain scenarios wherein you cannot initialize a static variable in one line. Say we'll be looking at frameworks in the later classes. We'll be looking at array list, hash maps, and things like that. So in that case, you can when you declare such a structure, a data structure to be a static variable, you can't perform that in one line. So you have to declare that, and then you have to use a static block. A static block is just given in two parentheses, and then you have to say static. And within this block, we'll be going and performing the initializations for our complex variables. And there can be many static blocks, so you can have many static blocks in a class, and the execution order will be first this block will be executed, next this block will be executed, and the purpose of this is to initialize the static variables. So let's go and see a static block example. Let's take a very simple example. um, Let me delete everything here. Let's take the demo class. This is also a class, right? Let me have a static block here. So this is static, and I'll have variable up static variable static int k, and I will initialize the variable as k is equal to 23 or something. So this block is actually used for initializing a static variable, say static int j, and j is equal to 43. Some initialization. So this block will get loaded and initialized even before this main method gets executed. That is the thing. So now let's go and print these variables here. Sys out. So we'll have j plus we'll have some space and then we'll print k. So you can see this block gets loaded and initialized before even main method kicks in. That's what they say. So 43 and 23 gets initialized first, then main method runs. You can even go and check that. We'll have sys out here saying I am running first, and we can have a sys out here to check this is main method. So now let's go and run this. So you can see this static block gets loaded and the variable is getting initialized even before the main method is running. So I am running first comes first, and then this is the main method next, and then the values from the main method get printed. As I told you, there can be many static blocks here. So you can have another static block, and I'll just not initialize. I'll have a statement here. I am running from the second static block. So now the order is this will be loaded, variables initialized, next this will be loaded, and statement printed. Then main method is going to run. Let's go and save and run this. Let's check the output. So I am running first, next comes I am running from the second static block, then the main method, then the output. So you cannot put non-static data inside your static block. For instance, say I have a class level variable int d, something like this. And I can't perform this. I can't do d is equal to 45. That will lead to an error because you need an object to actually access d. D is not a static variable, and you cannot put that inside your static block because static block is a class level block, and we cannot have any object level references here. See, cannot make a static reference to a non-static field, so this is not allowed. Hey, they can ask you questions like this in your examinations. That's why I'm telling you all these things. Okay, so we have learned so many about static today, so many things about static we have learned. I hope you are able to follow, and you're clear with what is a static block. A static block example is done. Now let us take up this interesting topic. can we overload the main method in Java? I'm asking you this question. We have a main method. Let me delete everything. Let me delete everything. Okay, the question we have now is, can we overload a main method in Java? What we have learned so far is we can overload a static method. We have seen that with an example. So obviously you can overload the main method. So let me go and overload this. What is overloading? You're just going to have public static void and the main. The method name, everything will be the same. But then the arguments will be different. Say if I say I take int a comma int b. I'm not taking an argument of strings here. I'm just taking two integers here. So now the static method is overloaded. And what is the use of this? Actually, what happens is from within this method, you can call the static method. Say, how will you call this? Say, this is demo class. That is the class name dot main. So I can pass 2 comma 3. So now I'm invoking this static method from within my main method. And I can also have a sysout here. Say I print the addition of a plus b. So that's how you can invoke this overloaded method. Let's go and check whether this one works. So the addition should be 5. Yeah, absolutely fine. The next thing you can ask me, can we go and pass some arguments to our main method in Eclipse? Say it's taking an array of strings, right? And that is called args. Can I pass an array of strings and invoke this main method? Is that possible? Yes, it is possible. And I'll tell you how to do that. For that, what I'll do is I'll just get this array of strings int I is equal to 0 and print that array in my program I less than args.len I plus plus. So this is nothing but what is args? It's nothing but an array of strings. I'm just running a loop to print the entire content in my array. So sys out and we'll print args of I. So printing everything that comes into this array. But how to pass data to this array? How to call main and pass data? For that, we have a process. We have to go to run configurations in Eclipse. And then we have to go to the arguments tab. Here we have to pass the array of strings. Satish, Ram, Tom. 3 strings I'm giving. Now I'm clicking run. So this will actually pass that here and this loop will print that Satish, Ram and Tom to the user. You see the array of strings getting printed. And what is this 5? This 5 is because of this call to this static method and we are printing a plus b. You can very well ask me, can I go and directly invoke this from Eclipse? No. The Java virtual machine will be searching for a method with this signature so that it can pass only an array of strings and work. And you can invoke this overloaded method only by a strategy like this. So that's how we overload a static method in Java. So when you overload a static method, even main is a static, we can very well overload that. I hope you all have understood the concepts on static. Thank you.